Okay, so YouTubers, the media, NASA, ESA, and investors are all getting scammed by space solar companies. I haven't seen any good videos on YouTube fully debunking space solar, so we're going to get into it today. I'm going to go through every reason why it's a terrible idea, and then I'm going to get into 4 times recently when people are getting scammed with space solar. Okay, so getting right into things. If you don't know what space solar is, it's basically the same thing as normal solar, except instead of just using a solar panel on the ground, you're instead going to use the solar panels in space to collect the energy, and then you're going to beam the energy down to the ground, supposedly to anywhere on Earth. Now, the main problem with most of these designs is that they use a geostationary orbit, which means that the satellite is going to be stationary in the sky. Okay? Now, since this requires it being 35,000 kilometers away, there's going to be a lot of diffraction and the light is going to spread out. So if you use a 1-meter antenna, it's going to spread to a 1,300 kilometer area. Okay? So obviously that's not acceptable. And so the solution that they propose is to use a 1 kilometer sized antenna. Now the problem here is that it's still going to produce a spot size of around 1 kilometer on the ground, and that's still only going to get 50% of the radiation to reach within that spot size. Now, getting into why space solar is proposed in the first place, the main problem with solar is that a lot of the light is just absorbed by the atmosphere, and then of course a solar panel only works in the daytime with good weather. So we can basically attribute 80% efficiency and 30% efficiency for those 2 issues. But now let's compare it to the issues of space solar. So here you're still going to have the 20% efficiency of solar panels, but this time you're going to have a bunch of losses within the satellite. And then of course, antennas are not perfectly efficient. So you're going to have about 70% efficiency for the transmit antenna. And then you're also going to have about 70% efficiency for the receive antenna. Okay, and then of course you're going to have side lobes when you're transmitting microwaves. And so only about 50% of the radiation is going to reach that spot size. Now, this works out to about 5% efficiency for both space solar and solar. So basically what this means is to produce the same amount of energy, you're going to need the same number of solar panels, except for space solar, you need to put them all the way into space. So obviously that's the key problem here. Okay, now another issue is cost. So to produce the same amount of power with solar, you really just need batteries. When it comes to space solar, you're going to need the same number of solar panels. Okay, so that cost is the same. And now you're also going to need all this satellite bus equipment. You're going to need a giant kilometer-wide antenna, which is super expensive and heavy. And then, of course, you're going to need to launch all of this in a geostationary orbit, which is very expensive, requires a lot of fuel, and a lot of rockets can't even do it. Okay. Oh, and of course, you're going to need your high-power transmission equipment, and then you're going to need 300 acres of land, and of course, that's going to be near a city or where people can actually use this power. You can't just put it in the middle of the Sahara. And of course, all this extra crap is going to be really bad for the environment, especially when you're launching it all into space, and all that fuel is getting expent. Okay, well, I hope you liked my TED Talk, but now we're going to get into the more sinister and juicy part of the video, and we're going to be going through a few of these space solar companies and showing off their completely infeasible and arguably fraudulent designs. And so we're going to start by reacting to Aetherflux, which I would say is the least feasible of these approaches. So let's get right into it. Okay, so this video is really what introduced me to space solar companies. And so we're going to see what the Aetherflux CEO has to say here.
CEO Baiju Bhatt, it's great to have you. Welcome.
Thanks so much for having me.
So what is the Aetherflux? What does this company do when it comes to helping drive power?
Yeah, so a company that I started called Aetherflux. The mission is to commercialize space solar power. And so the basic concept of the company is building satellites that when they get to space, they unfold and are sort of like mini solar farms that can then transmit power down to the ground to places where it's hard to get. So first applications that we're thinking about are places where it's really difficult to get energy. Think DoD applications, think remote mining. But both of these are applications sort of on the road to making this a broader energy solution for many use cases, all the way down to sort of industrial, commercial uses.
So you just sort of announced this company.
Yeah.
Right? The question is when can something like this actually happen?
Yeah. So I think one of the fascinating things about where we are right now with the space industry is we live in the Starship era. This is a new generation of space exploration, which is something I grew up sort of wondering if this was going to happen in our lifetime. And what we're really excited about is that that's one of the things that unlocks the ability to build these new applications in space. We are working right now towards our first demonstration of this technology. We hope to have it on a rocket sometime either at the end of next year or the beginning of the year after. That's kind of the time frame that we're thinking of doing a first demonstration.
Somebody pointed out today, I think.
Okay, so there he basically explained, what his company is planning to do, but now the host is going to ask a pretty funny question that really gets to the heart of the issue here.
What do we lose? You talk about putting these panels in space. What do you lose as opposed to a panel on the ground? Is it about finding a place to secure them and maintain them? What's the delta there?
So as a concept, the idea that we're working towards is building an actual energy grid in space. So imagine a constellation of satellites, each one that collects solar power and is servicing a network of ground stations all around the world. And so the idea eventually would be you put these solar farms in orbit and it allows you to distribute power all around the world.
Is it?
Okay, so you can see there he's basically coping. He doesn't really know how to answer the question. Okay, so as far as the actual details for Aetherflux, the basic idea is that they want to use infrared lasers and they want to have a low Earth orbit constellation. So I'll get into the problems with that later, but I'm just going to play this clip from this. It's around a 50-minute podcast, and he's just explaining the rationale for lasers.
Using infrared lasers.
Yeah, I mean, well, first of all, I think the idea of using lasers for power transmission it's been written about. There's actually been a decent bit of work done by folks at Naval Research Lab on this. I think there's a paper in 2019 where they did a demonstration of power transmission with lasers. I believe they set a distance record, or they set one of the longest distances for power transmission, and they demonstrated that you could do this terrestrially safely. So,
okay, so really quickly, just looking up that paper, what this is showing is you can see here a 2 kilowatt laser, and it's 400 watts of power across 325 meters. So, okay, great. So the big thing to know here is 20% efficiency. So that's the same exact efficiency as a solar panel using light from the sun. So that'll be really important to keep in mind. Another thing is this is only 325 meters. So the diffraction is going to be pretty much nothing in this case. Okay, now I recommend checking out the Aetherflux website. They have a bunch of I would say kind of funny stuff on there. But what I really want to show you is the Space News article. So you can see this demonstrator that they're talking about. They're talking about a kilowatt class spacecraft, okay? And we have a spot size of 10 meters, okay? So I'm going to show you how this translates. Okay, so here's the supposed design for Aetherflux. So they're going to have a kilowatt of power from an IR laser, and it's going to need to have around 5 meters of pointing accuracy if you want to accurately point onto a 10-meter array on the ground. Now, if you know anything about LiDAR satellites, you'll know that this is not possible with current technology. Usually they'll have something like a 10 to 20 meter or 10 to 100 meter spot size for their infrared laser, and they don't have anywhere near that level of accuracy, and they really don't even have that level of precision. So anyway, now let's get into this. So we have 1,000 watts, and it's going to be over a 10 by 10 area, roughly. So that's going to be around 10 watts per meter squared of IR energy. Now, if you compare that to the sun is around 1,000 watts per meter squared at the bottom of the atmosphere. So basically, this is not going to produce any power, especially compared to a solar panel. Okay, but really it gets even worse because if you just have one satellite, it's only going to have maybe a couple percentage of coverage. It's only going to be over your area for a small portion of the day. So to get this to actually work, you need a really big constellation, hundreds of satellites, something like Starlink, for example. And so this really isn't feasible. Another issue is that most of the Earth is just is just ocean. So most of the time, these satellites are just going to be over the ocean. They're not going to be able to power anything. Yeah, and so I think this design is really dead in the water. Okay, finally, yeah, for each solar panel that you're replacing, to produce the same amount of power, even the entire constellation wouldn't produce the same amount of power. And of course, the constellation is spread over the entire Earth. So, yeah, this design is really, it really just doesn't work. Okay, so for this next part here, I'm going to be referencing this article in IEEE Spectrum by Henry Bard. And yeah, I'd recommend reading this. I'm not going to read through the whole thing, but it has a lot of good stuff. And it really shows a lot of the ridiculous architectures that people have come up with over the years. But I really wanted to highlight was European Space Agency and how they're really taking space-based solar seriously. And it's really surprising. So if you read here, it said, the program aims to spend 3 years and 60 million or 65 million US dollars to figure out whether solar cells, DC to RF converters, assembly robots, and so on will be feasible and cost competitive. And so I just find that astounding that they're spending $60 million on a technology that, if you read this paper and if you're watching this video, you can understand that it's no better than solar panels on the ground. So anyway, this is on the ESA website. They're really taking it seriously, and I mean, $60 million is no joke. And I mean, I would basically consider that probably the biggest fraud of this video as far as just burning. Okay, one more thing. I just noticed this while doing my research on the ESA program. I'm here on Caltech's website, and you can see here, Caltech announces breakthrough $100 million gift to fund space-based solar power project. So they had this, billionaire apparently who just spent $100 million to Caltech on space-based solar. And I'm just imagining all the things that Caltech could do with $100 million as far as, astronomy or, anything else. So wow, that was really shocking to see that as well. In addition to the 60 million that ESA spent. Actually, NASA has done their own big study, and I couldn't find anywhere how much that cost, but I can imagine, based on how many authors there were, that it was a lot of work that is, in my opinion, was wasted. Just like what's going to happen with this Caltech stuff. Okay, so up next we have a brand new company, Solis. This also started in 2024. I don't know why all these space solar companies are starting in 2024. But you can see, we'll just go through their website here. They say there's no clean, firm, dispatchable energy technology other than space-based solar power. Hot take. So they go through why fossil fuels, solar, and nuclear are bad. Let's look at their claims here. So they think that the cost of launch is going to go down, and somehow this is going to enable them to do this for cheaper. So they basically have a large-scale kind of design. They want to have something like at minimum a couple hundred meters across. And so this really has all the same issues that GEO has, or a geostationary design has. And actually, they somehow managed to make it worse by changing to what's called a Monaya orbit. So you could look this up, but it's basically what's called a highly elliptical orbit. And in this case, instead of one satellite needed to power the ground station, you're actually going to need 3 satellites. And now, so in a geostationary situation, you're always going to have the same angle pointed at the ground station or the receiver antenna. But now in this case, you're going to be pointing from all sorts of different angles and different altitudes. And most of the time, the beam is not even going to fit onto the antenna based on just some, napkin math that I did. Yeah, so really this is just what I would say is a a worse version of the geostationary. Another thing that I would say, okay, so here they have a couple of these claims here that I think are misleading. So here they're saying the power beam can instantaneously beam power to anywhere on 50% of planet's surface, delivering power where and when it's needed. Now, this is not really correct. It's going to be able to beam some power to 50% of planet's surface, since it's mostly in the northern hemisphere. But the problem is that the angle that you're transmitting it at for all those equatorial sites is going to be really terrible. And most of the time, it's actually just going to be completely blocked by the Earth for any given satellite. Another thing they have here is their projected costs. Now, somehow they're saying that they're going to be cheaper than solar panels on the ground, plus batteries, which is pretty incredible. And then they're actually also saying that they'd be cheaper than gas, nuclear, coal. And anyway, if you read the NASA study, they basically completely refute this. And I don't know how they come up with this number, but I would say, I would just say this is completely misleading. The previous two companies, one thing you can say for them, for Aetherflux, apparently right now they're self-funded by their founder, which I think is good, really. And the other company, it really doesn't say, and they're not really directly advertising to investors. But this company, Space Solar UK, they actually, it seems very geared towards investors. They even have a for investors tab. We'll get into that later. But yeah, this also seems to be a pretty new company. And so, you can go on their website. They have a whole bunch of fancy stuff about their design. But they're basically advertising this really exotic, massive megastructure in space. It says a 1.4 gigawatt satellite. It weighs 2,000 tons, 1.4 kilometers in diameter. Okay, so this is really, really exotic stuff. You get down to here, they mentioned that they have Cassiopeia is the design that they have access to. If we go back to this article, you can see here's the so-called Cassiopeia concept, and there's the Burj Khalifa, the tallest building in the world. And so they're supposedly going to be building this thing in space. They think this is viable. As far as I'm concerned, it's just not a plausible design at this point in our tech. And even if it was plausible, it still wouldn't make sense. So anyway, that's probably 100 years out to be even possible. And then if you go to their for investors page, Okay, guys. So anyway, look, the point is Space Solar, it doesn't work. It's never going to work. All these companies are total scams. I think I made my point pretty well. I encourage you to go check out all those websites and papers that I mentioned. And you could go watch the videos and decide for yourself. Always think for yourself. But I just want to leave you with this really funny clip. It's Elon Musk basically spazzing out about space solar power. So anyway, I think that's a good way to end it. Anyway, this is my first video. Make sure to leave a comment in the description if you're seeing this, and especially if you disagree with me. If you think space solar is awesome, be sure to leave some comments and we can have a discussion in there. Anyway, thanks for watching, and I'll see you later.
See, that's the point I'm making. Take any given solar cell. Is it better to have it on Earth, or is it better to have it in orbit? What do you get from being in orbit? You get twice as much sun, best case. But you've got to do a conversion. You've got to convert it to photons, the energy to photons. Well, you have incoming photons that go to electrons, but you've got to do two conversions that you don't have to do on Earth, which is you've got to turn it to photons and then turn those photons get back into electrons. And that double conversion is going to it's going to get you back to where you started, basically. So why are you bothering sending them to bloody space? And by the way,
there goes our next cover story.
Maybe someone could stab that bloody thing through the heart. And by the way, electron to photon converters are not free, and nor is sending stuff to space. So then obviously super doesn't work.
So I think we have
Case closed.
Yes.
You'd think, you know.
I think we have time for
case closed.
Yes.
I mean, but no, it's gonna. I guarantee you, it's gonna come up another 10
They
times.
can just get a really long extension cord.
I mean, for the love of God.
So I think we have time for one more question.